Again, sorry for not having the smart presentation. Like I said, the decision was literally made a few minutes ago, doing what's best for you guys. So I'm going to go ahead and jump into the next section so I don't lose those days. Objective today is that you can use this law of sines to find missing angles on triangles. Okay? So of course, objective, the law of sines today. Okay? So here we go. You will use the law of sines to solve oblique triangles. You will use the law of sines to solve, if possible, the triangles of in the ambiguous case. And then we'll talk about what that ambiguous case means in a little bit. Find the area of an oblique triangle using the sine function. Solve applied problems using sine laws. We'll get through as much as we can.
Is this objective?
Go ahead.
Is this chapter similar to chapter 5?
No. This is.
Is it harder?
No.
Was that
No.
5 was hard.
Yes, yes.
Yeah, 5 is harder. I like the way.
You will feel much better about yourself in 6. I promise you. Okay.
This is the lowest point. Normally, I can't
Over one chapter?
Yes.
Bro, me and Yahtzee were together.
Note to self, push 5 to the end of the school year.
That's where I went ball, bro.
In 3, 2, 1. Thank you. So, let's get on with this. I will make a note of pushing that over. I think it seems like it would benefit people. I don't want people to feel like they're going to drop out when it's March. Maybe if it's in May, and you're like, it doesn't make sense to drop out because I'm this close. So. Okay. Hopefully everybody knows what an oblique triangle is. This is your vocab part. You're the one stealing my power. You disconnect all my stuff up here when you pull that out.
Really?
Not you specifically, but yeah, I've had my screen shut down. I've had stuff go, like, my computer will die at some point.
When?
Like, probably by 6 hours, I won't have power on. I'm like, what happened? Oh, someone took power. Because it bumps everything under. But anyways, be safe. No, just stay there. So vocab, oblique triangle. Everybody, right triangles has been like the thing for the last couple months, right? Now we're going to introduce this oblique triangle. And hopefully everybody knows what that looks like. It's just some triangle that doesn't have that right angle in there. Okay?
Is this lesson 6 or 5? 6.
Oh, I can't use it. Sorry. I'm not allowed to. I have to sneeze on my nose.
How would you add it? Can I just like pick it up? That's hard.
Okay. I got the wrong presentation.
It's actually bigger.
Okay. Oh, there's my picture. Yay. So it can look anything like this. There's no right angle.
You realize that you're always ahead of me?
I do that with problems too. Like sometimes I'll write a number, I'll say the answer instead, which is not good. So that's why I need to slow my. I don't have my presentation. Okay. No, I literally felt all this dust in my nose, and I have a sneeze in there that will come out.
I've been sneezing all day, but I feel a lot better than I did yesterday.
I'm glad that's good.
Yeah, I'm just congested. Other than that, I'm good.
Okay.
Wait, are you recording?
Yes, we are recording. So you can always go back and look at this again. Some more information about it. If you have an oblique, you're going to have one angle that's obtuse, and the other two will be acute.
What if they're all acute?
That's not
Yeah, that could happen.
Right, yeah?
It'd be like that triangle right there.
Yeah, it'd be like this one. So it has all three of them that are acute, or it has one of two. The other option. Okay.
Oh, so can you have either all three be acute or two acute and one of two?
Yes. You just can't have a 90.
Yeah.
You just can't have a 90. Or a 180, because that wouldn't be possible. But I'm gonna be quiet. If you had a 180,
It's a straight line.
you'd have a straight line.
Oh my god, Mariana.
But I'm being down another.
Quiet.
Now, do you guys remember from, probably not, from geometry, there was this rule that said the largest angle will have the largest side opposite to it. You guys remember that rule? The smallest angle,
Wait, hold up, say that again.
the largest angle will be opposite to the largest side. The smallest angle will be opposite to the smallest side. And that should make sense, right? If I got this thing going on and I close my angle, look at my fingertips. They're getting closer, 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 aren't they?
Wait,
So the
so-
bigger, go ahead.
The larger the angle, the larger the side,
Opposite to it, correct.
and then the smaller the angle.
Yeah, the larger the angle, the larger the side. The smaller the angle, the smaller the side. Okay. That whole idea comes into play when we're talking about the law of sines. What does that say? The relationship among sides and angles of right triangles defined by trig functions are not valid for oblique. Oh,
Is that true?
somewhat. Somewhat. It wouldn't be called the law of sines if we can't use sine, right?
Yeah.
And they would not use that for
Yeah.
trig. But what they're saying is you can't say, sine is equal to opposite over adjacent, kind of thing. Okay. Instead, there's a relationship in it, which is the easiest to remember. I love the law of sines. It's so easy. Here's what it looks like. See the ratios? Little a over the sine of a, little b is equal to the little b over sine b is equal to little c over sine c.
Ms. Munoz, where have I seen this before?
I've seen it in geometry.
Yes. Law of sines was in geometry. If you were in honor geometry, you should have done this
I didn't
as an
take it.
intro.
That's it.
That was so many years ago.
Yes, it was.
Oh yeah, I think I did that.
Let me guess, it was about almost 4 years ago.
Yep.
What's
That's a
up?
lot of years.
I think that
If you were in honors geometry, you probably saw this.
I didn't take geometry.
I feel like I don't even know I'm here.
What?
And I can help right now. Okay? We're good? If you have seen this version where they do sine A over little a,
Is it the same? Is it just
it's the same thing. I know I've seen this version before. It is the same thing. It's just a relationship in ratios on little a's, little b's, little c's. Okay? We're good? Now, caution also. Caution also. You're not filling everything in. I'm sorry. If you want to fill everything in.
Huh? No, we're not 11, man.
Oh, that makes me mad too. That upsets me too. When you're working with the law of sines, you're gonna end up doing 2 of these at a time only. So you might do little a over sine a is equal to little b over sine b. You might do this, or you might go little b over sine big B is equal to little c over sine c. Or you might be doing little a sine A is equal to little c over sine c. So you'll do any one of those 3 combinations, but you will not fill in the whole thing.
Does it
That
always-
is only a law that says, hey, the ratio of these is equal to the ratio of these, and those in turn are equal to the ratio of those. Kind of like that, what's up?
Would it matter what order like be going? Like could sine C equal sine A? Does it matter?
The order, what did you say? One more time for me.
Like so, you know how it goes? It's A over sine A is equal to B over sine B. Could it be B over sine B is equal to A over sine A? Is that still the same?
Yeah, that's the reflexive axiom.
Okay.
So yeah, reflexive axiom still applies. So I could write this backwards. I could go little b sine b equal to little a over sine a. Okay. All right, let's do this for real. For real. Look at this. Okay. So they want me to solve the triangle, and I already know that angle A is 64 degrees. I know that angle C is 82 degrees, and that little c is 14. What is the first thing that I want to find here?
Your sine.
The first thing I'm going to want to find is going to be little a, right? Because I have big C and I have little c, don't I? So I'm going to set up my ratio like this. 14 over the sine of 82 degrees is equal to, we'll call this x, over the sine of 64 degrees. Go ahead.
Can you find AB?
Yes, you can. But right now the logical step is find little a. Because they gave me, and I should write little a instead of x, because they gave me a, and they've given me something to create a ratio with.
Oh, and we know that.
Right? And we know that this has to be true, right? Now, what I just did doesn't make me right. Some of you saw, hey, B is easier to go after. You can do that, okay? Don't let me tell you what to do first. You should go do what's natural to you. Like in this case, you can already see B is going to be how much?
I don't know, I didn't add it.
How would you find it?
180.
Yeah, right? 180, take away those two. How much is it? But obviously that would be the next step, or the first step, and then little a would be your next step. All you want to find is everything that belongs to this triangle, okay?
Would it be 44, wouldn't it, really? 34. 34?
All right, cool. So now we have it for later. Let's get back to our problem here.
Okay.
Let's get back to our problem. How? Thank you. I want a, or little a, I should say.
Yeah.
It's being divided by the sine of 64. How do I get a by itself?
You would multiply by the sine of 64.
I'm going to multiply both sides by the sine of 64 degrees. So here, gone, and a is equal to this. Guess who is going to do that for me?
The calculator.
Texas Instruments.
Oh, hi, Texas Instruments. What are you doing?
Sine 64
First one was just
times 14, all divided by the sine of 82.
Are you in degree mode?
Ah, no, I'm not. Hold on. That's okay. Do not go and cancel that. Just go ahead and do your work. And once you hit enter, I got 4112. That's in radians. If you just go mode, go back to degrees, and then hit enter again, it'll spit it out again in. So I got 12.7.
Oh, me also.
12.7. Thank you.
Yeah, 12.7.
Boom. So there's little a.
I thought you asked for a highlighter. Oh my god.
That was.
I'd like to take a shower.
Oh.
Stays like this.
How do we find little b now?
You said it equal to one of the other thingies.
I'll put a line here. I know the C stuff, don't I?
Yeah.
That is 14 over sine 82 degrees.
Yeah. Now you also know.
I want little b, because that's the one I don't know.
Yeah.
I know that big B should be the difference between 90, 180, and these two, which is 34 degrees. Right? How many degrees in a triangle? This one's 82, this one's 64. How much is the other one?
Oh, okay.
Boom. Math.
Okay.
Boom. Math. Trigonometry. Okay? So this is going to be sine what? 34 degrees. And I'm going to do exactly the same thing as I did for A. I'm going to multiply both sides by sine of 34 degrees. I heard a 7.9. Can I get a second? Can I get a third? Thank you. Sold. There it is. Oh, I can't talk. That's actually a career. There's like competitions for that. There's competitions for that. No. Like people take that seriously.
What?
Wait, someone.
The people that sell, like the blah 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 blah. Auctioneers, thank you. I actually saw a little documentary on that. Farmers depend on them to get
Really?
more money, right?
Why?
Because if the auctioneer is good, that's the difference between.
At fair
Uh-huh.
is a lifesaver sometimes, because if your animal is not going for what you want it for, he'll point someone out and tell them that's what you're gonna buy it for, and then they'll just pass it around like that.
Nice.
So if it's only for say it starts at $1 and no one wants to go up from there, he'll point at someone okay, you're gonna go 5, and then he'll go around some more, and then
No, you're buying cattle. Cow, I mean, like.
Why for $1?
No, that was just
This
like
is an
an
example.
example.
No one's starting
Alright,
with $1.
buy 600.
Just an example. They start
But yeah,
at
but
$5.
you need good auctioneers.
My goodness, so wrong.
You know what? You think that it's easy?
I just got my brother up in there. Tell my brother.
Alright. 3, 2, 1. Thank you. Let's get back to here. Any questions on this law of science piece?
No.
I want you to go through right now as we're doing this lecture. I do want you to think of a question at the end, and we're going to ask for 2 of them. I hope I don't forget to ask. I forgot my last period. But I want to make sure that I answer questions for you. So, as a class, you need to come up with some questions here. All right, moving on. There's all the work. Look at all the stuff they made you do. They get crazy sometimes. Is that the same problem? Yes, it is. Look, you're my god. There's so much. Okay, you try. You try.
Watch, I'm not gonna be able to do this.
I give you 2 minutes.
What?
You don't need more than 2 minutes. Or you want 1 minute?
No, I'm trying
All right, 2 minutes, 10 seconds then. I forgot to put a bell work. Yes, we do. No, we're going to keep those. A lot of people are saying I'd like to keep those in my notes. So we're going to do that. Bell work is in your notes.
Bernie.
I just know because she's not gonna let me leave if I don't have one.
Well, you can show them your phone, can't you?
I don't know, I've never done it with her because she's a little complicated. Which one?
Oh my god.
I really thought it was because I never seen a highlight. See the so I was like, I'm just gonna go on you. Oh my gosh, that scared me.
How do you spell tough? Is it T-O-U-G-H?
Yes.
I was spelling free, C-R-E-M-E.
T-U-F-F. No, it's just U-F-F stuff, boy, but 2 big F's.
Wait, I was on. Put cream together. C-R-E-M-E. If you messed up, that's it. It's C-R-E-A-M.
I hate in this
I'll give you a little bit more. It's okay. With that kind of passion. key, which is your
Should
loud
the
noise.
calculator be in degree mode?
Yes. Make sure you're in degree mode.
Oh.
Munoz.
crap.
Give me a second, okay? Let me apply real quick.
You have tape? Oh, you do have tape. I need your tape.
What do you want this? Sure.
Yeah.
Here, want to check in?
Yeah.
Are we supposed to be in degree?
I got 37.
What?
Okay, I got 7.
Oh, I got. What'd you say? 5.2? Yeah.
Okay.
Sorry. I was like, I don't understand what's going on, but okay.
Chapter's already seen.
You guys look?
There we go. Look at that.
I don't know why I got 37. Oh, it's not the sign of 40, it's just 40.
It's kind of disgusting.
Look at the freaking. What does she look like? No, not the
Munoz. I'm so sore today.
Okay.
Luis, yeah, you get questions?
Oh, no. I'll do it right now. Remember, I didn't prepare this one.
Oh, that's right.
It was last moment. You guys good? All right, let's get through this.
I don't know what I'm
I got it.
All right, so let's see here. I'm just going to let the presentation do it this time because I don't want our time. So again, we know that angle A is 40 degrees.
Yeah.
Oh, and we know A and we know C.
Yeah.
So that means that B has to be, where is it at? 117.5?
Yes.
Cool. So everyone's good with that?
Yes.
Any questions on that from anybody?
No.
All right, moving on. Next part. Looks like we went after
They went after A first.
little a.
Little A first. Okay.
So we plugged in B, sine A, sine B. Should have been 12 times the sine of 40 degrees over sine of 117. So you ended up with 8.7.
Yes.
Thumbs up. Let me see some thumbs up.
Yeah, they just made it so much harder.
Yeah,
Huh?
they made that look weird.
They do. I'm sorry. They try not to skip any steps.
Skip every step.
Skip every step. Okay. So, all right. Next part was, looks like little c.
Yeah.
So you should have ended up with 5.2.
Yes.
Nice. You feeling good about this? Nothing like 5, right?
Greg, your face.
Oh, never mind.
was defeated.
Did you see Greg's face? He was like,
All right. Cool.
you were like, he moved slides and you were
The ambiguous case. The ambiguous case.
ambiguous. I like that word. Ambiguous.
What was SSA?
Just little C, 5.2.
Little c was 5.2.
Okay.
Okay.
You got it right, Lily.
I want. Let me go back this way so I can explain to you the ambiguous case, or try to as best as I can. You guys hopefully should remember that we used to have these rules, right? That kind of proves triangle similarity. Side, angle, side, all that business.
Yeah.
Okay.
I don't remember how to do it yet.
Okay.
Yeah. Same.
Can we agree? We have this length here. Okay, this is locked. This is locked. Okay. And I have another segment. I don't know. We'll call it A or something. Okay. And I have another segment. Let's say. I'm trying to. This isn't there. This isn't really there. I'm just using it as a baseline. That does not look straight at all.
It wasn't.
That's horrible.
It's better.
Is it a little bit better?
Yeah.
Okay. Here's the ambiguous case and what it's really talking about. Well, so we have some sides, we have some angles. Hey there, thank you. That's why she doesn't know. All right, so let's go back to this ambiguous case, okay? Actually, I want this to be a little bit laid down a little bit more. I think it's more visual that way. Okay. Okay. So let's say I'm going to use my. Does that work? Oh, that's way too long.
Around there.
All right. Anyways, thank you. Gracious.
Gracious.
Okay. Ambiguous case. I have another segment. I can't change the size of this segment, but I know I have another segment, so it could be the length of this pencil or whatever. Okay. So what I have to do is try to make a triangle. You know, I've got this base here. I don't know where. Maybe it is locked in, but I just know that's the base. I have this angle, the side A, and I have to add another side to it, and it's locked. We'll define it as B length. Okay. It's length of B. If I want to make a triangle out of this B length segment, can people visualize that segment going like this and just making me a triangle?
Probably not.
Well, there's only one way, right? Because the length will have to fit, right? Like here, let me do this real quick. Let's try like this. That hurt. So let's say that this was a fake floor, okay? Can you guys see that thing? Fake floor?
Yeah.
And if it continued correctly, I could put my triangle, I can close it off like this, couldn't I? And it looks like a triangle?
Yeah.
But is that the only way that I can put this piece on there?
Yeah, probably.
No?
Yeah.
That's the only way, right?
Yeah, because in order it wouldn't fit any way else.
Well, what if you bent it? Yeah.
What about that?
But there's like a line. Wait, so you're saying it's on the bottom like it's on?
Do you see the other triangle? Yeah, the base
Yeah.
it just kind of goes on. So we don't know that, but we know that this is fixed, and we know that this is fixed, correct? So I can make a triangle that looks like that, or I can swing this leg inward and make a triangle that looks like that.
I didn't think about that.
Say that one more time? Yes, technically. Okay? Technically, we don't know what it is. That's why I say it could be this length where it kind of stops there, or it could be this long where it stops right there. That, my friends, is the ambiguous case. Okay? I could go this way, I can go this way.
Oh, and
But you see how that changes all my angles?
Yeah.
Okay? It's so hard to try to draw it, but I think that made sense hopefully for everybody.
Yeah.
So let's talk about a little bit about this ambiguous case. Blah, 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 blah. On the live stream. So, there's a picture of it, right? Here's one triangle. Obviously, it's fixed. Here's our right triangle. Obviously, it's fixed. This can't make a triangle. And then over here, finally, we have what's called
Two triangles?
the ambiguous case. Okay? What?
That bothers me.
It does.
Yeah,
Why
but
does it
they're
not?
both
Why you
next
don't
to
want
each
to answer?
Wait.
Okay.
I should write this down.
So, yes, you should write this down. Consider a triangle which A, B, and capital A, one angle, are given. A is greater than H, and oh, you mean your notes? Okay.
And that's a right triangle, and then
Oh my gosh, it's so bright.
we have one triangle.
Look, dog.
Hola. Oh, yeah.
We should make Munoz a snap.
That would be literally. Let me add you.
I'm afraid of the snake.
Why?
Come on, man. I'm Snapchat you like
What's wrong with
while
Snap?
I'm working out.
Is there always only two scenarios?
No, it depends on the case that when you're looking at it. Because if you know all of them, you see how the first ones we kind of knew we could find them, but sometimes you only get certain pieces, and you have to determine whether that's even going to be a triangle at all. Okay. So let me tell you what I mean. you're going to be given segments. Sometimes you can determine whether it's going to be a triangle at all. So for example, if I have, let's say these were my 3 locked pieces, right? Could I make a triangle out of this?
Yes.
I could, couldn't I? I could kind of do this bit, boom, there's a triangle. So I know lengths, yeah, I succeeded. I'm okay at this game.
You're good at this game.
So I can do that, and when I got all 3 sides, I know definitely I can conclude it's a triangle. Yeah, because 2 sides, well, not necessarily. Not necessarily. It could be obtuse. Okay? Then we have where we were doing that whole scenario bit with the 2 sides. But what if I got rid of this side, and instead my length was this, and I got 3 sides? Hey, I know 3 sides make a triangle, right? Don't they?
Yes.
Not if they reach, not always. So no, it could be that one doesn't work. Even if I try to close it off, it's not going to happen. Okay? Sometimes it might not be that obvious. Sometimes it might not be that obvious, and you'll get some lengths where you're kind of trying to close that up, and they're just long enough to where they just lie flat on top of each other, and then they make a line. Okay? So no, so there's a rule that says the 2 shorter sides, have to be greater than the longest. Otherwise, because if they are equal, then you're just going to have a line. And if they're shorter, then you're going to get this like, they don't want to touch, never will happen. Okay?
And next it makes a line, then are all lines trying?
No. See?
That's what like made that.
Correct. That's the idea behind that. Okay?
I don't like the 2 triangles.
Yeah. I like triangles.
Bothering.
Munoz, I freaking hate my math lab.
Okay. Let's see what we can do with this triangle here. Let's solve ABC if A is equal to 50 degrees, A is equal to 10, and B is equal to 20. Let's try to find it all, please. So we need
And it definitely is a
B,
triangle because it says it.
C, and then we need little c. Okay?
This is gonna be like really.
So it looks like I can try to go for sine, right?
Yeah.
So I've got
Well,
10 over sine 50. That's going to
Yeah.
equal 20 over sine B. Okay?
yeah, because. Oh wait.
Okay.
You can divide it all by 20.
I'm going to save myself some time. And remember that other version I told you guys about?
Yeah.
I'm going to write it that way. Yeah. So I'm going
to.
to do sine 50 over 10 is equal to sine B over 20. So now I'm going to multiply both sides by 20. Oh, sorry. I crossed out the wrong ones. So what's 10 times sine 50 is equal to sine B. Okay? The 20 and the 10 will simplify, won't it? Oh, no, 2. Thank you. 2.
Yeah, me too.
2. Good looking out.
You're gonna get 1.5.
So looks like, let's see here, 2 times sine of 50 is equal to 1.53?
Yeah, I got it.
Okay. I still don't have B, do I?
No.
I still don't have B.
No.
I need B. What? Yes, I'm in degrees.
Yeah, we're in the.
That's the ratio of sine B.
Yeah.
So if I knew the triangle, technically, that's supposed to be the opposite of adjacent piece from trig. Okay? I want B by itself, don't I?
Yeah.
I know the ratio. How do I ask for angle B?
So then you would do sine of. Oh, you do the opposite of it.
Okay? So I'm gonna leave that answer here, and I'm just gonna go sine inverse of my answer, and it looks like what? What?
Yeah, I got the same thing. It says domain. Like,
It just said domain error.
yeah.
Anybody else get a domain error?
I got
Does
it.
that mean that it's not like applicable?
That means here it's not gonna work. That means that there is no such angle where this will work. And now we're looking at that one with that dangly piece. That no matter what,
Yeah, that no matter what.
you're not gonna make a triangle out of this. Okay? Go ahead.
I like how it says no solution at the top. As we know what's all that.
Okay.
I guess.
Here this is telling me that the sine of some angle is 1.53. Radians. Because remember that sine is opposite over hypotenuse? This, if I divided it, that's this number. Okay? So like if, for example, if I said, oh, the sine of some angle is 1/2, which is 0.5, that should give me 30 degrees, right? So here's what I know. I know that the sine of some angle is this. This is how we ask for the angle. I know the ratio, give me the angle by doing sine inverse. Correct, gives me the angle, the degrees.
2 days. 1 day.
Because it's not in radians,
Because a lot of international teams,
it's in degrees. Okay? Now if we did it over in radians, then I guess it would give me something like that. But it would still come out domain error. Because this cannot happen.
So 1.5 isn't your answer because it's not in Sine B.
1.53 is simply the ratio opposite over hypotenuse once I do divide it. If that was really true.
But it's not.
No.
No. Because we were going after angle B. And it turns out that there's no such angle whose ratio is 1.53.
Whoa.
1.53 is your sine, and then when you do the inverse, we get the angle.
Right. If there is one.
I was thinking them like they're the same.
They're not. No.
Oh my gosh, you know.
No. Okay? Cool. Let's move on.
So not being able to solve that part makes the whole question solvable.
Yeah, it does, because if there's no solution to that angle, then how will you ever find all the other pieces? There's nothing to create a ratio with. So if I can't get B, then I have nowhere else to go, do I? Because I don't know anything about C. You see that? Okay. Did you guys hear the question? Thank you for not having your phones out. The question was, now that we know that this has no solution for angle B, does that make the whole triangle unsolvable? The answer is yes. This is why. This is all the information that's been given to me. If I try to find angle C, can I?
No.
No. Since there exists no angle B that satisfies this, there's no way I can do 180 minus the other two. Or I can't even plug in little c because they didn't give it to me to find what angle C would be. So at this point it is unsolvable. And hopefully you guys didn't notice my
I didn't. I didn't see it.
no solution up top.
Oh no. Got me there.
That's like to remind you, don't worry, you're not screwing
No.
up. It's just that way.
I look here. I try to look at my notes all the time.
So let's say that you found B and it was like right, but then you couldn't find C and still B. It's like I knew it.
You can find certain pieces of it, but then you find that this one's not working. But eventually, still, it wouldn't be a triangle because you'd have a dangling piece in the scenario, okay? All right. Try.
Hold up, you had a question.
Who had a question?
Genevieve.
What's up? I just showed you. It's important to know if that and I'm trying to think like just off the top of my head. I'm thinking homes already. Okay? Homes have certain inclines and I don't know if you've seen them, sometimes they're nice and symmetric, sometimes they're not, okay? And what size my roof needs to be, so that it's not either gonna be flat, because flat, I mean, you can have a flat roof, it sucks, but you want something that's not gonna actually even sit there, and you have to be able to say, oh, you know what, that's gonna be too short, that's not gonna happen.
Green and yellow make
Okay.
it
Now,
lighter.
do I think it's gonna happen this way? Probably not. Probably not. But whoever's designing those
So, like,
truss,
did you start doing it already?
that's the word, right?
This is pretty
Hey, construction people, truss, right, in the house?
Yeah.
Oh, yeah.
Whoever's designing those truss will be doing that.
Lily
for
said
you.
two solutions as she looks up at
The engineer and the architect. Okay. All right, let's go for this one. Solve triangle ABC, please. Round lengths of sides to the nearest tenth, and angle measures to the nearest degree.
There's two solutions to this problem.
No. We'll give that away.
Oh, I did it again.
What is yellow?
Wait, did we round to the nearest degree?
Yeah.
Like whole degree? That was pretty.
I'm like, I was 32, but I don't
Oh, yeah.
Munoz, would you keep this would you keep this kind of
Yep. But
wait, what? Where'd you get the 50 from?
From
The sign.
yeah, the sign.
B.
Okay.
Okay, yeah, that's what I got. The angle B.
What does that say?
Oh, it's 50. Sorry.
Oh, I thought this said 5 degrees, because the 0 on
Ah, yeah. Okay.
Hey, where'd you put this? Yeah, where'd you?
It's after you. Well, yeah, never mind. I was gonna.
Oh, wow.
I flipped it. You did it. I flipped it and you put the signs at the top
Oh, okay.
because it made it easier that
Yeah, touche. Touche.
So then now that we know what those are, mark a blank.
I want her back.
oh,
What is this? Point.
It's .765. What'd you do? Yeah. Did you simplify? I mean, even if you didn't simplify it, I think.
Oh, sorry, not 0.5, 50.
Well, because you put it inside of it.
I want it. I got it.
Wait, where do I go? My ears?
Munoz, put it.
Hold on, you went too fast.
I'm sorry.
Not you.
I got it.
Dance and
Restart your fucking
Okay. 35 degrees. That means that my other angle is 50 degrees. That is an acute angle. I cut my angle here. According to my math, the other angle is 50 degrees, right?
Yes.
Which means it's going to look something like this.
Yes.
Do you guys remember the ambiguous case? For the oblique triangles? Okay, I have two angles, I can have two acute and I have one obtuse, correct?
Yeah.
But because these two alone don't even make 90 or are above 90, that means I can have the other possibility as well. If the sum of these two was 90 or more, then this is the only possibility, correct? Because that would have to be less than.
No, wait, more than 90.
Let me start over because I think I jumbled myself.
No, wait, I don't understand.
35 plus 50 is 85 degrees, correct?
Yeah.
That means that either this angle is huge, which means 95 degrees, okay? Or it could be that the other angle here is 50, okay? Because these two are less than 90, I have more playroom, I have more wiggle room. So you see that?
You're trying to make, wait, no.
If these two were 90 or more, then I would only have one option. But because these two together are less than 90, that means I have wiggle room to swing this out and make this the 50 degrees.
Wait, no.
Oh.
Oh, okay.
And make this one the obtuse angle.
Okay.
Or not even obtuse, another,
Another cute angle.
yes.
No. Why?
Because they didn't specify where it was, right?
And then what?
Because these are two less than 90.
Why would you put 50 down there, though?
That's what I'm saying. Here's where you can have.
So
Okay.
how can the 50 move?
They want to know how.
Do we know where it is?
He didn't say where it was
You
at.
should stay put. Well, for like what I did, like, 'cause you did the math.
Are you good with this?
Yeah.
Okay. Is that the only angle where I can get this as a solution? Try. In your calculator, do the sign of. What's mine up? Real quick here. Do the sign of 130.
130. Sign of 130.
Okay, 45 and 90.
Yeah, I got 0.7.
Because there's a couple different ways where that's going to be possible, right? Sign is up into quadrant 1 and in quadrant 2.
Yeah.
So it could be the 50, or it could be the 180 minus 50, which is 130. Damn, that trig came back and
Why
haunted
would I
me.
put it in the calculator? I did the sine inverse of that 0.7.
So here's 50 degrees, correct? And I got that the sign of that was a positive 0.765.
Yep.
But where else could my sign be that positive number? Could it not be here as well?
Yes. It could be there.
Right?
I don't know how that.
Remember reference angles, alpha prime? Let's see here. How could I do that? Let's say that this was 3, 8, I don't know. I'm just making numbers up here, okay? I don't even know they're real, okay? So let me ask you this. If this is 50 degrees, what's the sign here? 3 over
3 over
8, right? So there'll be 3/8. Now let's reproduce that so that this is also 50 degrees. That means that this would be 3, 8, and -5, correct? What is sine of 50 degrees here?
3 over 8.
It's also 3 over 8. All that we know is that the sine of some angle is this. But it turns out that I actually have two possibilities here, don't I?
Well, how do you know when that happens?
So,
How do you know when that happens?
How do you know that there's another?
I usually look for the two angles that I have. If they're less than 90, that's a good time to
So
look.
if they're less than 90, you have another one.
I could probably have another one. And I want to check anyway. Okay? Yeah. That's why I said I will check it in my math and see if other angle also, if it fits. Does that make sense?
I kind of want to figure this out now.
So if I see that those two angles are less than 90, I would check this one and 180 minus this one.
Oh, so then it would
And if
be
the
all-
180 minus this one gives one to me as well, that's a possibility. Okay? We'll talk more about this on Monday. But there's a possibility that I could have the other angle down here, correct? Which would still be a positive cosine? But that's only talking about cosine though. Hold on. There's too much noise. Let me end this.